Assalamu alaikum. This is Kamrul Hassan, lecturer, Department of Mathematics, Milestone College. My dear student, I hope you are fine. Today I want to discuss about ellipse, which is very important for your upcoming exam. In this video, just I want to give you a good idea about ellipse. Three important things for ellipse. First two things is these 2 points. These 2 points is known as foci, and third thing is distance. Look at this. Distance always twice a. Now let us consider a point on anywhere on ellipse. Suppose here is P point. Look at this, P of XY. Now this point, these 2 points are foci. So this point is S and this point is S prime. Now we can connect these 2 points PS and this point PS prime. The sum of this line, the sum of these 2 line segments PS and PS prime always PS plus PS prime always twice A. That's why this line segment is A and PS this line segment is also A. And here another thing is, suppose anywhere we can take another point. Suppose this point is here. This point is Q, and we can connect these 2 points QS and QS prime, and also this part is A and this part is A. So the sum of these 2 parts QS and QS prime is also twice A. That's why QS plus QS prime is also twice A. Now after this part, now here we can consider this line segment from this point, this point and this point. Suppose this line segment is this part is a vertex A and this part is vertex A prime. These 2 parts is known as vertex A and A prime, and the midpoint of these 2 foci here S and S prime, midpoint of these 2 points S and S prime is here. This point is C. This is the midpoint of S and S prime, and also midpoint of this A and A prime. And look at this here, A and A prime is known as major axis. A and A prime is known as major axis, and here that's why this part C and CA prime and CA, this part is A and also this part is A. The length of CA prime, the length of AS is A. This part is A and this part is A. That's why A prime is twice A. That's why A prime equals to twice A. And here now we can draw a perpendicular. Now we can draw a perpendicular on major axis which is passes through the center. So here this is the perpendicular line, and this is known as Y prime. This point is B and this point is B prime. And look at this here, B and B prime, this part, this line segment is known as minor axis. This part is B and B prime is known as minor axis. One thing is important here. Major axis always greater than minor axis. And here look at this C prime, this part is also known as semi major axis, and which is represented by A, and this part C B prime, this part is this part is semi minor axis, and which is denoted which is represented by B. That's why this part B and BC, this part also B. So we can write here the minor axis B prime, minor axis B prime equals to B plus B. That's why 2B plus B equals to twice B. So we can write here A prime is the major axis, which is the value of twice A, and here B prime is the minor axis, which is twice B, Now we can draw a vertical line on these two foci. Here this is the one kind of vertical line, and here this is another vertical line. These two vertical line is known as lattice rectum. These two vertical line, here suppose this point is L, and this point is L prime, and this point is N, and this point is N prime, and here L N and L prime N prime is also known as lattice rectum. And here after this part we can draw another vertical line. This is M and Z. We can draw another vertical line here. This is M prime and Z prime. Now this is known as MZ, and M prime Z is known as directrix. Now here we can draw another perpendicular. From this point P, on this directrix. So we can draw a perpendicular. This is the perpendicular. PM is the perpendicular on MZ. And now the ratio of, look at this, the ratio of SP and PM is constant. The ratio of SP and PM is constant. The value of constant is always less than 1. Then and the locus of the point is called ellipse. So we can write here, look at this, SP by PM equals to constant here E, and E means eccentricity, so the range of E, it will be 0 less than E less than 1. Now we can say that the definition of ellipse. If on a Cartesian plane a point moves in such a way that the ratio of distance of that point from a fixed point and a fixed line on the same line is constant, and the value of constant is less than 1, then the locus of the point is called an ellipse, and this is the ellipse. Now I want to discuss about some basic formula about ellipse. First we need the standard equation of ellipse. Look at this here, standard equation of ellipse. It will be here x square by a square plus y square by b square equals to 1. This is the standard equation of ellipse. And here look at the board. This figure when a is greater than b, and this figure will be when b is greater than a. Now some basic formula. Look at this. For this figure eccentricity will be, for this figure, eccentricity will be, here look at this, A is greater than B. So eccentricity, it will be E equals to square root A square minus B square, square root A square minus B square, and by A. And here eccentricity, when B is greater than A, B is greater than A, so it will be square root here B square minus A square, B square minus A square by B. Now look at this, coordinates of center. For this figure, coordinates will be C, so center will be C of 0, 0. Here abscissa will be 0 and ordinate will be 0. And for this figure, center will be same as here C of 0, 0. And now the coordinates of two foci. Here look at this, for this figure, S and S prime are two foci. S and S prime are foci. So we can write here the formula of foci, here plus minus AE, 0. 0 means, here look at this foci is on x-axis. That's why y equals to 0. That means ordinate will be 0. That's why here 0 and plus minus AE. Look at this. This is center. This part will be positive and this part will be negative. That's why plus minus AE, 0. And here, and this part A and A prime, this is the major axis. This is the major axis. And here the coordinates of two foci, there here this part S and S prime, these are two foci, and here the major axis will be, for this figure major axis will be B. That's why it will be 0, plus minus BE. Here look at this, abscissa is 0 because this major axis, these two foci S and S prime is on y-axis. That's why abscissa must be 0. And here, and this part positive and this part is negative. That's why we can write here plus minus BE. And now terminal point of major axis, or coordinates of two vertices. This point and this point. And here for this figure it will be, look at this, plus minus A, 0. And here for this figure it will be the terminal points of major axis, this part B and B prime, B and B prime is major axis. That's why here 0, plus minus B. This is the formula of terminal points of major axis. Now formula number 5. Look at the board. Here A is greater than B, so we can use this figure for coordinates of two foot point of directrix. Look at this, MZ and M prime Z prime, they are directrix of this ellipse. And here the coordinates of two foot points of directrix, it will be plus minus A by E, 0. And here when B is greater than A, then we can use this figure, and here the formula of coordinates of two foot points of directrix for this figure, it will be 0, plus minus B by E. This is the formula of coordinates of two foot points of directrix. And another one formula is formula number 6, coordinates of two terminal points of minor axis. Look at this. Here B and B prime is the minor axis, and here A and A prime is the minor axis for this figure, and B and B prime is the minor axis for this figure. And here we can write 0 comma plus minus B, here plus minus B, because minor axis is B, that's why B, and here the abscissa is 0 because this minor axis is on y axis, that's why here abscissa is 0, and here the formula of coordinates of two terminal points of minor axis for this figure, it will be here plus minus A comma 0, because here A and A prime is the minor axis, and which is denoted by A, that's why here plus minus A, and this minor axis is on x-axis, that's why y equals to 0. Now formula number 7, equation of major axis. Look at the figure. Here major axis is A prime is on x-axis, that's why y equals to 0. This is the equation of major axis, and here equation of minor axis. When A is greater than B, then we can use this figure, and here minor axis B prime is on y axis, that's why x equals to 0. And here when B is greater than A, then we can use this figure, then our formula will be equation of major axis will be here. Look at this, major axis is B and B prime, which is on y axis, that's why x equals to 0. And here minor axis, equation of minor axis, formula number 8, equation of minor axis is here A and A prime is the minor axis, is on x axis, that's why we can write here y equals to 0. This is the equation of minor axis. Now formula number 9, equation of lattice rectum. So we can write here equation of lattice rectum will be x equals to plus minus A E, and when B is greater than A, then equation of lattice rectum will be y equals to plus minus B E. This is the equation of lattice rectum. And formula number 10, here equation of directrix. So equation of directrix it will be x equals to plus minus A by E, and here for this figure equation of directrix will be y equals to plus minus B by E. This is the formula of equation of directrix. Now formula number 11, length of major axis, length of minor axis. Look at this. Here A and A prime, the distance between 2 points A and A prime is major axis, so which is denoted by A. So major axis it will be A prime equals to twice A, and for this figure length of minor axis it will be here B and B prime is the minor axis for this figure, so we can write B prime equals to twice B, and for this figure we can write the length of major axis it will be, look at this, B and B prime, it's B and B prime equals to twice B. Twice B is the major axis of this figure, and here, and minor axis, the length of minor axis, it will be A and A prime. That means A prime is the minor axis of minor axis where B is greater than A. So we can write A prime equals to twice A. This is the formula of length of major axis and length of minor axis. Now formula number 13. Distance between two foci. Look at the figure. Here S and S prime are two foci. So distance between two foci S prime equals to 2AE, and for this figure distance between two foci S and S prime, it will be S prime equals to 2BE, because B is the major axis for this figure and A is the major axis for this figure. That's why S prime equals to 2AE and S prime equals to 2BE. And now formula number 14. Length of lattice rectum. Length of lattice rectum. Here L prime is the lattice rectum. So length of lattice rectum equals to L prime equals to, here for this figure it will be 2b square by A, and for this figure it will be L prime equals to 2A square by B. This is the formula of length of lattice rectum. My dear student, no more today. See you again in the next class.